Today in this lecture we will discuss some properties of linearly independent set and linearly dependent set. What are the properties? Okay, the first property is that any set containing zero vector is always linearly dependent. It means whatever the set S is, v1, v2 dot dot vn and 0. If we add zero vector in this set, then this set is linearly dependent. Okay, so we can prove easily. Let c1 v1 plus c2 v2 plus dot dot cn vn plus cn plus 1 into 0 equal to 0. So it will be linearly dependent if at least one of C1, C2, Cn or Cn plus 1 is non-zero. So if this is equal to 0, this is also 0, this is also 0, and this, if we take non-zero, then this whole term will be 0 because this is 0, because of Cn is 0, this term will be 0, Cn into Vn. Similarly, C2 dot v2 0 because of c2 is 0, c1 is 0, so this term is 0, so this term is 0 0 0, or this term is 0 because of just 0 vector. So all the additions will be 0 vector, but one of the coefficient is non-zero, hence this set is linearly dependent set. So whenever set contains zero vector, then that set is always linearly dependent. Okay, so second properties of linearly independent set is what? Empty set is defined as always linearly independent. Okay, this is defined, so this is not must. Now Li set contains distinct vector. What does it mean? This property is very important. Okay, Li set, let we have a set v1 dot dot vn and be linearly independent. Okay, and we need to show, what is to show that this is distinct, means vi not equal to vj where I not equal to j, and I comma j will be from 1 to n. Okay, so we need to show this is distinct if this set is Li. Okay, we know that if we show that this is not distinct, if we will able to show that it is not distinct, means not at Li, then we are done. Okay, P imply Q. If we show not Q imply not P, this will hold. So let Vi equal to Vj for some I lies between 1 to n, and also j will be in 1 to n, I not equal to j. Now we show this set is linearly dependent. So how will we show? Okay, so we can, now we have c1 v1 plus dot dot cn c1 v1 plus dot dot ci vi plus dot dot cj vj plus dot dot cn vn equal to 0. Now what we conclude here, that c1 v1 plus, we can write as vi equal to vj, so ci plus Cj Vi we can write, because Vi equal to Bj, so then we can write Vi at the place of Bj, so we can take common Vi and dot dot dot, it will be Vn Cn equal to 0. Now if we take Ci equal to minus Cj, this term will be 0, and take all other Ci equal to 0, then all the expression on the left side will be 0, equal to 0, but Ci may not be equal to 0. If Ci not equal to 0, Cj also will also not equal to 0, and say we got what? Ci may not be equal to 0, equal to minus Cj, and all other Ci is 0, and so we got this set S is linearly dependent. Okay, if you have some queries, please ask in the comment box. Okay, now we will proceed to next properties. This tells us a set S of vectors. We have a set of vectors which is Li. Imply that each finite subset of S is Li. Means it tells us that a set of vectors is Li. Let us assume we have a set v1 dot 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 to vn. Now it tells us it will be Li if and only if its each finite subset will be Li. Okay, we can prove easily. First assume this one is Li. Okay, and this is very useful when the set is infinite. Okay, if we have infinite number of element in the set S. So if we take infinite element, what will be this dot 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 this. Now is Li, when we say this set is Li, if we take finite member from it, and that finite member should be, this finite member should be L. Okay, so now next properties of linearly independent set is, we have a matrix A1 dot dot AK. We have a submatrix. This is the set of matrices is Li, then their transpose is also Li. So it can be proved easily. Let C1 A1 plus dot dot Cn An equal to 0. This is a zero matrix. Zero matrix of size edge of AI. Okay, this is the zero matrix, and their size will be the size of the matrix A. So now this is Li, it means will implies Ci will be 0 for all I. Okay, now taking transpose to first, if we take both side transpose, what will we get? C1 A1 transpose plus dot 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 Cn An transpose will be 0, and we know what, that this Ci's C1 dot dot Cn is same as of C1 dot Cn, and if this is 0 factor, so we can write C1 equal to 0 equal to C. Now next properties is every subset of Li set is Li. Means we have a set v1 dot dot vn, and this is Li, and what is to show, take any subset of this. Right? v1 to vm. Without lots of penalty, we can take m is less than n. Okay, so to show this is also li. Every subset of li set is li. To show, okay, so this is li. So we have c1 v1 plus cm vm equal to 0, and to show c1 equal to 0 dot and c2 equal to 0 also similarly cm equal to 0. Actually we can write c1 v1 plus cm vm plus 0 into vm plus 1 plus into vn equal to 0. Okay, now if we see whole expression that it is v1 to vn and we have this is li, it means all the coefficient will be 0, but this coefficient is already 0, so c1 will be 0 equal to cm equal to 0. Hence proved is a statement that every subset of li set is li. Similarly, we can easily prove that every superset of linearly dependent set is linearly dependent. Please try. Okay, now this is very important that we have three distinct vector. Okay, and we have a li's making by three distinct vectors. So, and it tells us if u v w was distinct, and if u v w this set is li, imply that u plus v, u plus w, v plus w is li. Okay, first assume this is li, so this is li, and assume this is li, means u plus v, u plus w, v plus w is li, and so u v w set is li. Yeah, I do first part, and it will be easy to prove. Let u v w is li. What it means, c1 v1 c1 u plus c2 v plus c3 w equal to w 0, and it will imply c1 0 equal to c2 equal to c3 equal to 0, means all the constant terms were 0. Now to show this is li, means alpha 1, if we take c1, that will be not okay, so c1 u plus v plus c2 u plus w plus c3 v plus w equal to 0. Now our aim is to prove c1 is 0, c2 is 0, c3 is 0. So we have c1 u plus c1 v plus c2 u plus c2 w plus c3 v plus c3 w equal to 0. Now if we solve it, we can take common here u, and from here u. Okay, so it will be c1 plus c2 u. Similarly, we can take v common from this term and this term, so it will be c1 plus c3 v, and we can take common now c2, we can take common w from this term and this term, so it will be c2 plus c3 w, it is 0. Now we know that u v w are linearly independent. What does this mean? That C1 plus C2 is 0, C1 plus C3 is 0, and C2 plus C3 is 0. If we solve these three equations, we will got C1 equal to C2 equal to C3 equal to 0. Okay. Other way, please try. Now we have a questions which is asked in GATE 2016, and it is very similar what we prove here, that if xyz is basis, what does mean by basis? It is Li and dimension should be 3. Dimension of vector space should be 3. So dimension of vector space is 3 and this is Li. Need to show this is basis of R cube. It means we only need to show this is Li. Similarly, as we have proved this properties, we can prove this also, that this is basis or not. Similarly, we can so this is Li, and if this is Li, it will be basis. Okay, so please solve these questions. It will be easy to solve.